Devastating floods, destructive tornadoes, volcanic eruptions, hurricanes. Weather-related events have a profound effect on human activity and the global economy. That's why the researchers at the University of Wisconsin's Cooperative Institute for Meteorological Satellite Studies are so enthusiastic about their mission to improve weather forecasting using satellite technology.
We're all weather weenies, which is a fond way of saying we're people who love the weather. We have employees from the University of Wisconsin, of course, that's most of us. SIMS has about 130 people. We also have employees from NOAA, the National Oceanic and Atmospheric Administration.
Professor Vern Sumi, considered the father of the weather satellite, founded the center in 1980 after early success developing meteorological instruments in the 50s and 60s.
This satellite was amazing because it was the first one to make the measurements of Earth, and it began to pave the way for the next generation. And so for the first time in the 60s, they were actually able to see what the cloud distributions across the globe look like at one particular time. And that was revolutionary. Back then, it was such a big deal to see clouds over the oceans. Nobody had seen those before.
Using computers to visualize satellite data is a heavily used technique today. But this revolutionary idea has its roots at the facility.
The next thing to look at was, well, how does this evolve with time? And one way to look at that evolution would be to do essentially what cartoons used to do back then. You take a stack of them together and you kind of flip through them. And so they digitized all that data, and then they needed the software tools to analyze that data to do those animations. And again, that was a brainstorm that Sumi had.
The result was the prototype of the storm tracking videos we see routinely during weather forecasts today. The facility functions as a nerve center for the collection, utilization, and storage of weather-related data.
Pretty much any kind of weather satellite data that's available throughout the world comes into this building. We are the mecca of satellite meteorology. So these satellite dishes collect data from satellites all over the world. So we bring in about 150 gigabytes a day. And then we process it and distribute it to users across the nation and across the world. And we distribute about 500 gigabytes per day. We have a complete archive of the US geostationary satellites going back about 30 years now. The biggest roadblock for incorporating all this satellite data is the quantity of the satellite data that we get. We need better ways of storing the data and better ways of accessing the data. So we need to collaborate with statisticians, mathematicians, and computer scientists.
The expertise of SIMS researchers is in high demand during severe weather events such as thunderstorms, hurricanes, and volcanic eruptions.
If we take the Icelandic volcano, we can do real-time analysis and locate where that volcanic plume is geographically as well as how high it was. And then that data was distributed not only to the United States weather forecasting agencies, but also to the Europeans so that they could help track where that plume was going. And then we do the same thing with the hurricanes. When a hurricane is approaching the US or even as it's developing, and all that data gets transferred to the National Hurricane Center. And they use that in their forecasting of where the hurricanes might be going.
When NOAA and NASA need to verify the functions of expensive new satellites, they turn to the Cooperative Institute for Meteorological Satellite Studies for that testing.
The most recent one that we worked on was GOES 15. That was launched, I think it was in May. And it's up there now. We tested it out. We worked with NOAA and NASA to assess that, yes, it's a good satellite. It's doing good things. The satellite itself costs a couple of $100 million. So, yeah, they're expensive.
SIMS scientists are combining their own custom-designed software with the incoming satellite data to create new early warning systems.
So if you've been in a plane, you've probably experienced turbulence, and a lot of times it's clear outside, so the pilots can't see it. So we're developing algorithms, working with NOAA, working with the FAA, in developing methods to automatically detect those regions and find ways to getting it to the pilots so they can use that in their flight planning.
Researchers at SIMS are also influencing the future of meteorology by helping to design the next generation of weather satellites.
So what we're looking for is the next generation weather satellites, and that will have better capability in terms of its spatial resolutions, pixel resolution, as well as the number of wavelengths that it actually looks at. So for example, once a thunderstorm gets going, radars can find them and they can track them very well. But what we really need to know is where are they going to occur? And so we're developing new ways of simulating future satellites on how they can predict where the thunderstorms are going to initiate.
These future satellites may move researchers one step closer to the goal of making the perfect forecast.